Okay, we're back, and I just finished up reviewing weeks 1, 2, and 3. Financial functions. I didn't really review week 1, but that's kind of NRGY 101 stuff, converting things to kilowatt hours. I also spent a lot of time just going over if statements and evaluating different options for different tax versus payback incentives. Okay, now let's get into week 4. And I've got the solutions here. Week 4, air compressor. Okay. And I kind of want to pull up Doty's week 4. I think he did a pretty good job here. So let's just kind of bang through it. So the 3-phase 10 horsepower motor is going to run for 10 hours a day. It's going to run for 5 hours a week. That's how many hours per year. Weeks per year. I think so. That might actually be 50. But anyway, that's how you get to that number. Hours per year. No problem. Let me make this a little bit bigger. Okay, it's going to run for 12 months per year. That's how many hours per year. Here's the 3-phase service fee, $57.80 per month. The demand charge is going to be $37.44. The demand factor, $7.25. Here's your energy charge, 6 cents per kilowatt hour. Next time, put your units right there, please. Energy used, that's the hours in use. So C27, oh yeah, rating of motor, kilowatts. So if it's going to run for that many kilowatts, let's just see exactly where that's coming from. Yeah, here's kind of the tricky part. Okay, so kilowatts per horsepower. Oh, I see why he's getting a little bit of a discrepancy, because there's actually 0.746 kilowatts per horsepower. That's fine. 70% load factor to come up with a that's kilowatts. That's not quite right. Okay, let's go look at the 100 horsepower 3-phase. 15 operating cost. Yeah. Okay, this is where the little bit of discrepancy comes in. Not bad. I think I gave you full credit here, Sean, but it's just a little different. So let's look at Fraser's. Fraser's answer. Okay. Annual operating hours. Use factor. Oh, this is slightly different. I'm going to pause. Sorry. Okay, I take it back, Sean. I think you got it exactly right. I was looking in slightly the wrong place. Okay, so let's go back here. Yeah, this is the correct answer. So I'm going to look at Fraser's solution. So 1349 is the final answer. The service fee was $6.94. Somehow it's easier for me just to look at myself and talk to myself while I'm doing this thing. Okay. Service fee was $6.94. And that's M9 times 12. So the monthly service fee is $57.85. That's where that's coming from. The annual demand, so we're looking at 52.5 times 12 times the demand rate. Okay, so where's this original power of 52.2 coming from? Let's just double check on that. Okay, so he's using 7.746 as I mentioned before. So M14, that's the nameplate horsepower, so the more powerful it is, obviously, the more demand you're going to get, times M15, which is the load, so it's not going to run at full capacity, it's only going to run at 70%. It's the mechanical load. Convert that into, so going from horsepower to watts, or horsepower to kilowatts, 0.467, and then we're going to divide that by M16, which is the motor efficiency, which is just listed at 100%. Okay, so that's where our annual energy is going to come from. Or I'm sorry, that's where our annual demand is going to come from. Quit doing that. Okay, and the annual energy, here's the original energy times the energy rate. So the energy rate is given. Let's look where the energy itself comes from. That's just the hours per year times the power in kilowatt hours. Okay, so that's fairly straightforward. All right, tiny pause, then I'll get it back to problem 2, which asked us to compare the 100 to the 150. Okay, this next problem, I think what you came up with there, Sean, is a little bit different from Fraser. There's just a couple little subtleties, but your basic approach was correct. So I'm just going to use Doty's solution here as the correct one. So factors given in problem, and again we're on problem 4. We are on problem 4. No, sorry, problem 2 of week 4. Thank you. I'm just a little bit under the weather here. Okay, hours per year, 8760. Man, I keep doing that. Control Z, don't do that. 8760 hours per year, 12 months per year. The product of those is number of hours per year times the use factor, which is 40%. The three-phase service fee, I think this was a little different in Fraser's solution, but that's okay. $59.30 per month. That's basically paying to have the three-phase service coming right to the house there. Demand factor for anything greater than 300 kilowatts. So as soon as you go above that, you're going to pay this premium on a monthly basis. And you're only going to pay it if you hit it once, so $7.43 if you go over it. And there's the energy charge. So all of that's given. Nice job here, Sean, in your color coding too, by the way. All right. So power demand, we've seen that before. I-384, where's that coming from? So let's go all the way down here. Average kilowatts. So this is the data. So, yeah, just taking the average of all that data. There's your I-384. That was all given. Average power used is just the average energy used is the hours in operation times the power. Energy is power times time. There's your energy cost. There's your fee. Boom. Okay. So that's the cost to run the 100 horsepower motor. Now, the 150, it's coming from P70. Let's hop over there. So we're going to call them P70. So the 150 horsepower motor is only running at an average of 3401. That's basically where your main savings is coming from. Same hours of operation. The cost is the same. The energy charge per kilowatt hour is the same. but you're going to pay less overall, because the 150 horsepower compressor is not going to have to run as heavy. Okay, so that's it for week 4. Let's keep cruising. Pause. Okay, guys, so I'm essentially caught up. I'm in week 5, and I'm smack dab in the middle of grading week 5, and I've got basically 5 minutes before I go into the live session that I promised Joe Bauer that I would get into. So it's 2 minutes to 2 my time, 5 minutes to 2 my time, 5 minutes to 2 your time, and let's just see where I am. I'm going to do a little bit of real-time grading. So let's see, Doty 4. Okay, I'm going to close out of that. Nice job. Save. Fine. Let's look at week 4 air compressor, Doty, learning unit 5. Great. Okay, so I'm digging my way through this thing, and problem 1. Okay, this all looks pretty good. Here are your months of the year. These are kilowatt hours used per year, average power factor. Here's the kVAR H used. This is the if statement. J6, J16. Oh, yeah. So here's the J16 is the power factor. So if you're under that power factor, you have to pay. If not, you're good to go. So that's where the 0s and 1 come from. The annual cost then is just the sum of all those guys. The monthly average is just the average. The minimum cost was 0. You had 0 charge on that one. Maximum monthly cost, just using the max function there. Standard deviation, same thing. Standard diva of all those numbers. Take a quick pause, compare that with Fraser.